Recently, scientists have challenged the Big Bang model again and questioned the reliability of the Big Bang. Are you curious? The Big Bang model, which was established 120 years ago. Why do some scientists always want to prove and deny the Big Bang? What do they want to prove? Obsessed with the origin of the universe, what does it mean to us? In the 1920s, after discovering that our universe is expanding, Belgian cosmologist Georges Lemaitre speculated that if the universe is getting bigger and cooler, it was once smaller and hotter. All the energy was squeezed into a smaller and smaller area. The logical conclusion to this is that if you rewind the universe, from the very beginning, all the energy of the universe would exist at a single point in space. This starting point would be infinitely hot and dense. However, it is this infinity that leads to ambiguity. Einstein's theory of relativity can be used to predict the movement of objects under the influence of gravity. But when you start adding infinity to it, no equation can well describe the universe. The initial moment of origin. What happened? Or what caused the universe to start expanding at an infinitely hot and dense starting point? We cannot know what happened before it. What might have happened? Any evidence from before then? Or signals would have been swallowed up by the hottest incinerator created by the universe. It happened somehow. And that's all we can be sure of. In the first moments of the universe, changes in temperature and density caused matter to begin to form. After 1 second, the temperature of the universe dropped to 100 billion degrees Celsius. Although it was still very hot, it was cool enough for matter to begin to form. 99 seconds later, the universe cooled to 1 trillion degrees Celsius. Powerful forces began to come into play. Protons and neutrons began to combine to form hydrogen and deuterium. Hydrogen and its isotopes are the most common elements in the universe, but hydrogen is not the only one. Helium, with 2 protons, was also quickly created. By mass, almost 76% of the matter in the early universe was hydrogen, and 24% was helium. Very rarely, however, another proton would merge with the other 2 protons to form an isotope of lithium, bringing the number of protons in these atoms to 3. By mass, this accounted for only 0.0007% of the early universe. But this is where the mystery comes from. By examining spectral data from stars, we can assess the distribution of elements in the universe today. What we see is roughly in line with predictions. Our Sun, by mass, is 71% hydrogen and 27% helium. 2% is other heavy elements. These proportions are similar throughout the universe. This is strong evidence for the hot Big Bang and that our equations are correct. However, our prediction for lithium is wrong. Although the predicted lithium content is indeed very low, the predicted value is actually 3 times higher than what we see. In other words, when we study the spectra of pristine stars, we don't see the amount of lithium we should see. There are more mysteries surrounding lithium. Lithium-7 is the isotope we tend to see in the early universe. This means that the nucleus of a lithium atom has 3 protons and 4 neutrons. But there is another isotope of lithium, called lithium-6, which has one less neutron. It should be less stable than its counterpart, and also less common, accounting for only 2 out of every 100,000 lithium nuclei. The ratio of lithium-6 to lithium-7 is too high. There is 1,000 times more lithium-6 in the early universe than there should be. So, what does this mean for the hot Big Bang model? Does our most trusted theory about the origin of the universe really need to go back to the drawing board? Not necessarily. There are two possibilities. One involves rewriting what we know about the Big Bang theory. But there is another explanation. When faced with something like this, one of two things must be true. Either our observations are wrong, or our model is wrong. It's hard to completely discard the hot Big Bang model. Nothing else can explain the existence of the cosmic microwave background, radiation so well, or the amount of hydrogen and helium we see in the universe. Those elements almost perfectly match the predictions of the hot Big Bang. It seems too perfect to be a coincidence. That said, scientists are becoming less certain about this model because it's not holding up. Stephen Hawking, once a major proponent of the universe beginning from a single point, later changed his mind. In his book A Brief History of Time, he said, "The work of Roger Penrose and myself is now widely accepted. Today, almost everyone assumes the universe began with a Big Bang. Singularity, perhaps ironically. I have changed my mind, and am now trying to convince other physicists that, in fact, the universe began without a singularity, as we shall see later. It disappears once quantum effects are taken into account. These quantum effects are too complex to be discussed in this video. And this doesn't necessarily solve the lithium problem, even if it's true. But it does highlight an evolving branch of physics and cosmology, for which a complete explanation has not yet been found. Perhaps our model will one day be adjusted in such a way that the lithium problem disappears, even if the broad strokes of the theory remain, letting the lithium puzzle fit nicely with hydrogen and helium. Another option is that there is a problem with our observations, and there are likely some reasons for this, since the amount of lithium being discussed is very small. Once you look back a long time, you can see the interstellar rings, the exact amount present in them. The only way to detect the composition of the interstellar medium is to let light pass through it, and then see which shapes are blocked in the spectrometer. This can tell scientists what elements might make up a particular nebula or dust cloud. But this becomes increasingly difficult the farther away the target is. Eventually, it becomes completely impossible to get an accurate estimate. Instead, scientists can only focus on the spectrograms of pristine stars. These spectrograms do not necessarily represent the entire universe at that time. Stars are a special case. What happens inside them could change the amount of lithium present in them, transforming lithium into something else, while also increasing the amount of lithium-6, although it is difficult to guess what this process might be. If our observations can be improved, and we can better measure the lithium content throughout the early universe, perhaps the numbers will fall back into line on their own. Perhaps the lithium problem never existed in the first place. Ultimately, the answer to how the universe was formed will never be complete until all available data matches the predictions of the theory. Whether it is lithium or other problematic elements in the universe, such as the excess of gold out there, all these numbers must be consistent. There is still much to learn about the origin of the universe. To understand, I do feel how incredible we are to be able to learn and infer events that happened billions of years ago. Matter itself has formed correctly, using only our telescopes and our minds. That picture, how it all began. The grand picture is waiting to be assembled. However, how the universe was formed. It is built on a foundation of order that allows us to unlock its principles, unravel its mysteries, and reconstruct the configuration of its parts. One day, I am confident that we will also solve the lithium problem, as we await the answer to our ultimate origin. Some questions are too important to go unanswered. In fact, science is the search for origins, and as an astronomy enthusiast, Lomowo can't wait to see the day when this puzzle is finally complete.